and today we will be speedrunning Unit 6D to 6G. So first I'd like to apologize. When I was going through editing all of the videos, I realized we actually didn't make a tutorial on these four. And so I'm going to quickly speedrun it today. I'm going to assume that you guys already know how to use while loops and you're very confident. If you aren't, maybe you should check out the previous videos on Unit 6. So let's get right into it. First, given a sequence of non-negative integers where each number is written on a separate line, the sequence ends with 0. Find how many elements are in the sequence are equal to its largest element. So the first thing we want to do is we want to initialize a counter variable. A maximum variable. Say the max element, and right now let's set it to actually first let's get our input in. So let's get I is equal to input. Very simple. And the maximum element is equal to I first, because that's the first number we've input. So right now the largest number we've seen is the first number. And we want to also get the count of the amount of numbers equal to this largest number, and let's set it to 1. Now we want to check while our input is 0. So while I is not equal to 0, because remember our sequence ends in a 0. Not equal to 0, then we want to check if I is equal to the max. Actually, we want to input a new I. No, we want to check if it's equal to the max element. So if I equals max element, and actually make this count 0, then we want to add 1 to the count. So count plus equals 1. And then that's very simple. And next we want to just input our new I equals int input. And this code should really do the trick. So finally we can print count. Now I'm actually forgetting something. If I is greater than the max element, then we actually want to update the max element in the count. So first we want to say if I is greater than the max element, then we want to set the max element to I, because that's our new largest element, our new maxima. And we want to set our count back to 1, because right now we only see one element that's as large as that. Elif I equals max element count equals 1. Okay, so this looks good. So if we copy our example input, as you can see, it prints the correct output 1. We copy this other example input. Let's see what it prints out. Ooh. Do I not know? Maybe I'm looking for extra inputs. This is interesting, because right now it's not printing anything. So let's try that again. Maybe I've made a mistake. Oh, never mind. It was just REPL being slow. Whatever. So we submit this code. We can see that it's working perfectly. And yeah, just be careful, because sometimes in these REPLs, even though it might seem that your code's not working, you might just want to just hit reload on that page, because sometimes it's the REPL's fault and not yours. Right, on to the next problem. So 6e, given a sequence of non-negative integers where each number is written on a separate line, sequence ends with 0, determine the length of the widest fragment where all the elements are equal to each other. Okay, so we want to first get our input number. Say I equals input, which just inputs a number, and we want to initialize some variables. So the first variable we want to initialize is what's the previous element. So previous element is equal to I currently, and we also want to have a count of the current size of the fragment. So frag size is equal to set 0, and oh, sorry about that. So, and finally, we want to store a maximum fragment size, which we'll also set to 0 right now. So now we want to loop over while I is not equal to 0. We want to check if I was equal to the previous element, which means that the fragment is 1 more long. So if I equals previous element, then we want to add 1 to the frag size. So frag size plus equals 1. And now we want to check if the fragment is larger than the maximum fragment we've seen. So if frag size is larger than max frag size, then max frag size is equal to frag size. And finally, we want to reset the fragment size if it's not equal to the previous element. So else frag size is equal to 0. And is equal to 1 actually, because we've seen a new element, so it's the new element. Its fragment is one thing, right? Now we want to just input the next number, so I equals input. Okay, so now if we want to determine the length of the widest fragment, and we want to return the length of the widest fragment, which is stored in our max frag size variable. So if we press run on this code, copy this example input, as you can see, it returns the correct output. Oh, what's wrong? So teacher expected to see 4. Oh, I see we're not updating our previous element over here. So we should set at the very bottom, previous frag size equals 1, previous element is equal to I. Right. Now, sorry about that. Let's run this code again, and as you can see, it's working. So the problem there was that we did not set the previous element. We didn't update the previous element whenever the previous element changed to reflect that the fragment was with different numbers. Okay, so next one, Fibonacci. Okay, so Fibonacci numbers are 1, 1, 2, 3, 5, 8, 13, 21, 34. Very interesting mathematical concept, but I won't elaborate on it too much right now. So given a positive integer n, we want to print the nth Fibonacci number. Remember, this is the first Fibonacci number, this is the second, third, fourth, and so on. So we want to say our input, which is the nth fib n. This is n. We want to get the nth Fibonacci number. So say n is equal to input. And how do we calculate the Fibonacci numbers? Remember, we add up the previous two to get the next one. So we want to store the previous Fibonacci number, the previous Fibonacci number and the one 2 digits ago. So let's say prev number is equal to 1, because remember the first numbers are always 1, 1. And like the second number, the previous number, so prev number is also equal to 1. And we want to loop over n times. So we can say while n is greater than 0, then we want to set our well, actually, here's a little trick we can do. We can set the previous. We can set the so we have to create a variable called number, and let's set that to the previous number plus the previous number. Next, we want to set the previous number to our previous number, shifting it 1 down, and we want to shift the previous number 1 down too. So we want to set previous numbers equal to the number. And finally, this code should print the Fibonacci series. So we print number right now, and we run this code, and we put 6 in. Sorry, as I said, we put 6 in. Oh, where am I going? Oh, sorry, we're not subtracting n. So after here, we should be subtracting 1 from n. So to make sure we hit the bottom number. And so by taking away 1 from n, this while loop will repeat n amount of times. Let's see if, let's see if this code should work now. 621, oopsies. So we're actually 2 numbers off the correct number. So we want to make sure while n is greater than 2, right? Because we're starting with the first 2 numbers, remember that. So we have no need to calculate any of these. So if we run this code again, it gives the correct number. So it's a bit interesting to see if we print at each number the Fibonacci series is taking us. As you can see, we have 2, 3, 5, 8. And if we extend the series a bit, we can see that it is printing all of the numbers correctly. And if you don't understand why, still, then you might want to toy a bit around with the code. Just make sure you know what each line of code is doing, and maybe rewind the video. So in this case, I think the final case we have to consider is if n is less than 3, because if n is less than 3, we just print 1. So we want to check what n is at the very start. So if n is greater than 2, then we run all of this very nice code. But otherwise, if it's less than 2, then we just want to print 1, because the first 2 numbers are just 1. And so if we submit this code, we should see that it is now working. Finally, on to the last challenge. So 6G, Fibonacci index. So Fibonacci numbers, yep, we get that. Given a positive integer n, determine if it's the nth Fibonacci number for some n. If it is, print such n, otherwise print -1. Okay, so what we want to do is we want to create our Fibonacci stepper series again, which calculates the Fibonacci number. So we're going to take this code from the previous challenge. And so we have previous number equals 1, previous number equals 1, right? Except that now we want to loop over it a certain amount of time. So the input number we have is n. So n equals input. And we want to keep on getting the next Fibonacci number as long as the Fibonacci number is less than n. So while n is greater than or greater than number, actually greater than previous number, sorry, because we're storing it in that variable. We want to get the next Fibonacci number. And so this while loop will stop updating once we've got a Fibonacci number that's equal to or larger than n. So right now let's just print n, and let's just print that number. So if we run this code and put 8, as you can see, this is n. Let's put n is equal to that. And so that. This is just to show you guys. So number is that. So if we run this code, put 8n, we can see that our n variable is equal to 8, and our number is also equal to 8. So in this case, they are equal. But what happens if we put something that's not a Fibonacci number, like 10? Well, as you can see, our n is equal to 10, but our number is equal to 13. So to check whether it is a Fibonacci number, we want to print whether they're equal or not. And if they are equal, then we know it's a Fibonacci number. So if n is equal to number, then we want to print the index. Print index. Else, we want to print -1 because we know that n is not a Fibonacci number if they are not equal. So finally, we want to initialize a counter to count what Fibonacci number we're at. So our index is equal to, say, 2 actually, because we're starting to remember with the first 2 Fibonacci numbers. And every time we loop through, we want to add 1 to the index. And finally, we want to print our index over here, which will, oops, sorry about that, which will print the index of the Fibonacci number that n is equal to. So if we run this code, put 8, as you can see, it returns 6, which is because 8 is the 6th Fibonacci number. If we put something that's not a Fibonacci number, it returns -1 as expected, and so our code works perfectly. So that's the end of these while loops. And if you want to learn more Python, I suggest you continue on to our next episode, which is about for loops. And as always, make sure to like and subscribe so that you get more of our videos and you get to learn more about coding. See you next time.